in this section 4.6, we're gonna talk about isosceles triangles. We've mentioned isosceles triangles before, and we're gonna go in a little bit more details. We've mentioned that isosceles triangles are triangles that have at least two sides congruent, and those two sides that are congruent are actually called the legs, right? They're called legs, just like a right triangle has legs. Same for that one. And this other side is called the base. All right? Now, so you've got two legs and a base versus the right triangle, which has two legs and a hypotenuse. Hang on. These two angles that are created by the base and a leg are called the base angles. Okay? And then the other angle, which is not congruent, is called a vertex angle. So in an isosceles triangle, you've got two sides that are congruent. Those are called legs. And then the two angles that are formed by the base and a leg are also congruent. Those are called the base angles. The third one is called the vertex angle. Okay, so let's talk about the isosceles triangle theorem. It says, if two sides of a triangle are congruent, then the angles opposite those sides are also congruent. Okay, so that's exactly what I was talking about. If these two are congruent, right, then these two base angles must also be congruent. So if AB is congruent to CB, that means angle A is congruent to angle C. Okay, and that could be in any orientation. So if you have, a triangle like this, D, E, F, and suppose these two are congruent to each other, which two angles are congruent? E and F have to be congruent to each other, right? They're the base angles. Okay. Now, the converse of this is also true. The converse of this says, if two angles are congruent, then the sides opposite to them are also congruent. So, if this angle is congruent to this angle, that makes the triangle isosceles, and we say DE is congruent to EF. Okay? All right. So, moving on. Let's take a look here at what we have. All right, so we need to find the value of x. First glance, you look at this and you're like, oh, isosceles triangle. That means the two base angles have to be congruent to each other. All right? So if that to the top right is 3x plus 8, then so is this one, 3x plus 8. And so now I have two of these 3x plus 8 angles. So two of those plus the third one, that's all three angles. It equals 180 degrees. Okay? We're here. Yes. So, yes, it will be 6x plus 16, and then plus 2x plus 20, that's 180. No. He was saying, can you set 3x plus 8 equals to 3x plus 8? You can't do that because then it'll just be 0 equal to 0. Okay? All right. So this one here, it'll be 8x plus 36, right, is equal to 180. Subtract 36, and 8x is 144. So x is 18. Okay? All right. So next, we have GH congruent to HK. We have HJ congruent to JK, right? And notice how I need to put like different markings for those, right? And we are told measure of angle GJK is equal to 100. And I want to know what is the measure of angle HGK, this one. All right, that's what I want to know. So if I make this a little bit larger, so, okay, so here, right, this triangle to the right, that's an isosceles triangle, and these two are the base angles. So how much is each one of those angles going to be?
40.
40, because if you subtract 100 from 180, you've got 80 left over, which you then have to distribute between these two, okay? So that's going to be 40.
Isn't it like a linear pair that the other side?
Okay, yes. So now these two together add up to 180. That means this is going to be 140 here. Okay? And I also know that these two are congruent to each other. So 140 subtracted from 180 is 40. That leaves 20 for each of these. So measure of angle HGK is equal to 20. Okay, yes?
How do you know that the 40 and the 40 are...
Triangle ABD is an isosceles triangle, and ACD is a right triangle. Measure of angle 6 is 136. We want to find measure of angle 3. Okay, so same situation. This triangle here, ABD, is an isosceles triangle. So if I subtract 180 minus 136, how much does that leave?
144.
44, right? It leaves 44. So that 44 has to be distributed evenly between these two because it's an isosceles triangle.
20.
So 22 each.
90 minus 36.
And this one, right, is 90 degrees. 68. So measure of angle 3 is 68. Okay? All right. Next one. All right, so let's take a look at this proof. We have two proofs and then we have a couple more to do. So we have triangle PQR. We're given that PQ and QR are congruent. QS is congruent to PR. So let's write all that down. Okay, so when you have like given triangle PQR, that's the diagram. You don't really have to copy it over here. So I'm just going to say PQ is congruent to QR. QS is congruent to PR. We want to prove that angle P and angle R are congruent to each other, right? So to prove that two angles are congruent to each other, this is the triangle chapter. We're probably going to have to prove two triangles are congruent and then do CPCTC. Okay? So this is the given. All right. So let's see. Let's take one of the given. Well, if we have a pair of perpendicular lines there, then I know that these two are right angles, right? So let's write that down. So that's angle PSQ and angle QSR are right angles. What's the reason for that? Yeah. Not that. It's the definition of perpendicular lines. Okay? Number 3. There you go. Yep, now those two angles are congruent. because right angles are congruent. All right angles are congruent. Okay, so now take a look at what we've got. I have a right triangle back to back with another right triangle, right? The hypotenuse of each of those right triangles is congruent, and so is this one. So what is that? Right, but then how are the triangles going to be congruent?
Side angle side.
Is it? So okay, so look.
Okay.
Oh, no,
That's not a thing. SSA.
Is ASS a thing?
HL.
Oh, HL. HL. So, when you have two right triangles, if the hypotenuse and one leg are congruent, then it's HL. Okay? So now I can say triangle PQS is congruent to triangle RQS, HL, and then angle P must be congruent to angle R, CPCTC. Okay? All right. Yeah.
But if you are
Okay, but this, look at what this is saying. It says to write a two-column proof of the isosceles triangle theorem. So we're proving the triangle theorem, so we can't use it. But we're proving. This is the reason, so this is the reason why in an isosceles triangle, if two of the legs are congruent, then those base angles must be congruent. So we just proved it. This was the proof of this theorem right here. Okay?
So why do you put like some in red?
Okay. Just to highlight.
Oh.
That's it. Okay. So here we go. CA is congruent to BC. And then KC to CJ. I'll do double ones here. C is the midpoint of BK. And we need to prove that these two triangles are congruent. So these are congruent the way I've labeled, but also C is the midpoint of these two, so it makes these also congruent. So it's like all these segments are congruent to each other. All right, so let's go to CA. Let's go with the given first. Oh, and also C is the midpoint of BK given. All right, let's start with that midpoint, right? Yeah.
can you do B, A, J, and K are all congruent?
Well, you have to prove a little. So you know that B and A are congruent, and you know that J and K are congruent.
The top ones are congruent.
Right. So yes, logically in your mind you can make that connection, but that's the thing about proofs is you have to go step by step and you have to make an argument with no holes in it, right? So since C is the midpoint of BK, I can say that BC is congruent to CK, and that's the midpoint theorem. Okay? Now, okay, so BC, and so these are now congruent, right? Okay, now, can I now say that BC and CJ are congruent, right? BC and CJ are congruent? They are, because it's transitive, right? CK. Right, so look at what we can say. So we can say BC is now congruent to CK. No, CJ, sorry, CJ. Right? That's transitive. Okay, so now these two are congruent to each other. And also, AC and CK are also congruent to each other. This is all because of the transitive. AC and CK transitive property. Okay? Yes. So now angle BCA is congruent to angle JCK, vertical angles theorem. And what do we have now to prove the triangle is congruent? Because we're done. SAS.
Why can you skip over 3?
No.
Why do we are we able to use like the
So yeah, but then so it's you can't, so right now you have enough, it's SAS, because remember you can't have AAA, right? So like the 3 angles, like having the 3 angles won't help you as much. So ABC is congruent to triangle JKC SAS. Yali, what was your question?
why do you have to do step 3?
Huh?
Yes. Why do you have to do step 3?
Because it's only with step 3. Okay, well, so before step 3, I knew that the 2 angles, the 2 sides here were congruent, and I knew that the 2 sides here were congruent on their own, but there wasn't a tie-in to say the sides from triangle 1 are congruent to the sides from triangle 2.
Oh.
That's what did the tie-in.
So
Step 3. Step 3 is what said that's congruent to that, and that's congruent to that.
So you have to have them like congruent to like the triangle.
Correct, right? Because how can you prove 2 triangles congruent if 2 sides here are congruent to 2 sides there?
Okay.
You can't have 2 sides congruent internally within the same triangle.
Yeah.
Okay, so use the diagram to answer the following. Okay, so with these ones, if ABF, so angle ABF, this one, is congruent to angle AFB, this one. Okay? So look, this can get a little confusing. The way these are made, each of these are independent of the other ones. So each statement here is its own standalone statement. So when I take a look at that, right, what I want to do is I want to highlight the triangle which it's talking about. So that's the triangle. And inside of that triangle, those 2 bottom angles are congruent. That means what's congruent to what? Right, AB is congruent to AF, or BA and FA. Okay, so now for the next one, all right, I erased this and I need to start again. DAE is congruent to DEA, this one. Do you see that? So the triangle there is which triangle? It's this one. Do you see that? Yeah? So what's congruent here? Yep.
You can also just look at it by like how it's written.
Yes and no. Always be sure.
Like I would know how to check it like if I look at the triangle.
So let's do another one. Let's do another one and see what we're talking about. So FA is congruent to AH. Okay, so that's highlighting that triangle. So what angles are congruent? Right, but wait, can we just say F and H?
No.
Because that can mean a whole bunch of angles.
Well, AFH is congruent to angle AHF.
Correct. Okay, AFH, AHF. Okay, last but not least, some corollaries. A triangle is equilateral if and only if it's equiangular. So why? Because, because if a triangle is equilateral, right? Well, look, these two say that these two are congruent, right?
Oh.
Yeah? And then if I say this one and this one are congruent, then that would mean this one and this one are congruent, and just like that, it just makes all the angles equal to each other. All right? So basically, you cannot have an equilateral triangle that's not equiangular, and you cannot have an equiangular triangle that's not equilateral. And how much does each angle of an equilateral triangle measure then? 60 degrees. We've done that before. It was never a secret, right? Okay. Triangle EFG. I'm yelling because it's so exciting. So triangle EFG is equilateral, and EH bisects angle E. Okay, equilateral means 60, 60, that whole thing is 60, but if that bisects, then how much is each one? 30, 30. Okay, so I know that without even reading what is asked of me, right? Find measure of angle 1 and measure of angle 2. Well, I just did. Measure of angle 1 equals 30. Measure of angle 2 equals 30 as well. And now I need to find x. So basically, how much is x?
Well, can you do 60 plus 30 plus 15x equals, or you can just do 15x equals 9.
Right. So since these two add up to 90 already, in this triangle, this one must also add up, the 15x must also be equal to 90. So 15x equals 90, and x is 6. Okay? And with that, we have finished the chapter.